Okay, I want to look at division of fractions, rational numbers. So the idea of division really answers the age-old question of how many of something are in something else. So we're partitioning the three wholes in the halves and then counting out how many halves we have, and we can see there's 6 of them. Same thing here. We partition 3/4 into 1/8, and then we count up the 1/8 and we see 6. If you notice, they're using the circle model, and I really don't like that because it's very limiting as to what you can do. Halves, quarters, and eighths are fine because it's easy to partition a circle. Now, I was raised on symbols like a lot of you, and I was raised this way. I'll do this one. I was raised that, boy, if you want to do 3/4 divided by an eighth, well, you simply flip the second one or took the reciprocal and you multiplied. Get 24/4 was 6. And that's the way I learned fractions. It was all by symbols. We don't get to do that anymore because we want kids to have understanding. And I didn't understand what I was doing with division of fractions, honestly, until I saw a lecture when I was in my doctorate program. I have a master's in applied math, and I didn't know the concepts behind dividing fractions. So that's what we're going to concentrate on in this course, those concepts. Okay, so how many 3/4 are in 3? Well, I'm going to use a number line model. I'm going to have to partition in the quarters, which are easy. Notice I'm just doing halves and halves of halves. Now I'm going to count the number of 3/4. So let's go to red. So here's 1 3/4. Here's 2 3/4. There's 3. And then 1 2 3, looks like there are 4 3/4. So that's partitioning to see the number of 3/4 that are in 3. And again, if I did 3 divided by 3/4, I would have simply done 3 times 4/3. I would have canceled, and I got an answer of 4. But just by partitioning, I'm getting a different representation. You know, you think Lesch's model. So I'm getting a much different representation of what this fractions and what this 4 means. Okay, this isn't in the book. These are problems I really like because I add context to something, and this is going to lead me to discover what the meaning of a reciprocal of a fraction is. So I need a wall. Here's my wall. I'm going to break it into quarters. And I know a gallon of paint covers 3/4 of my wall. So my paint covers 3/4 of a wall. So this is 1 gallon. That's really the hole in this problem. The hole is my gallon. Now this that's left out here, this is part of a gallon. How much of a gallon do I need to finish my wall? And if you quickly said 1/4, you were wrong, because this is 1/4 of the wall, but it's not 1/4 of the gallon. This is one of, your gallon has 3 pieces of this size. So this is one of 3, or 1/3 of a gallon. So how many gallons do I need to cover this wall? I needed 1 and 1/3. That's 4/3 of a gallon. So if my answer is 4/3, how does that relate to the 3/4? That's the reciprocal. Okay. Just to kind of show you a number line model. Actually, if you look at this bar above the number line, it's just like my wall model. Again, I'm looking for how many 3/4 are in 7/8. I know it's a division. Here we've got it partitioned. So I have 1 3/4 in my 7/8. This is how much of a 3/4? It's 1 part, and the whole has 1 2 3 4 5 6 of these parts. So this is 1/6 of a 3/4. So how many 3/4 are in 7/8? There's the 1 and the 1/6. If we were to do the division, 7/8 divided by 3/4. Gotta move this. This is 7/8 times 4/3 is 28 divided by 24. 4 times 7 over 4 times 6 is 7/6, which is 1 and 1/6. So our partitioning model is lining up exactly and helping explain the division. Okay. Hopefully I'm going to tie everything together here. How many 5/3 are in 1? Here's 1. I need another one because 5/3 is greater than 1. So now I'm going to partition everything into thirds. So there's 3/3, 4/3, 5/3. So here, that's my 5/3. How many of these 5/3 are in 1? I don't want purple. Need a new color, green. Notice that this 5/3 is broken into 5 equal pieces. 1, 2, 3, 4, 5. Okay, that's my denominator. The total number of equal pieces in the whole, which is my 5/3 here. Now in 1, that's this. How many of those pieces are there? There's only 1, 2, 3. So there are, they're supposed to have a many in there. Sorry. How many 5/3 are in one? The answer is 3/5. How is that related to the 5/3? It's the reciprocal. Let that sink in for a second, because now I'm going to erase this. Because I don't think I have a, no. Should have added one more page here, sorry. So this is the takeaway. The amount of a fraction in one, or you can think of the whole, is by definition the reciprocal of the fraction. And that's what I didn't understand until I was sitting in a class like this, watching, I was helping a teacher and they did this and the students' eyes lit up and my eyes lit up. Because I was like, I have a master's in math, never knew this. So I'm going to finish with one more problem. Erase, erase, erase. Doing this on the fly, or would have had a blank slide already done. I'm going back to our gallons of paint. How many gallons of paint needed for 3 walls? Okay, remember our gallon of paint covered 3/4 of a wall. So the problem I'm doing right here is how many 3/4 are in 3? That's the division problem. I'm going to draw my 3 walls. And if you recall, we said that it took 4/3 of a gallon to cover each wall. If I have 3 of those, I'm going to add them. Whoa, I'm adding. That's repeated division or repeated addition. So I'm doing repeated addition. And now we can link that to, well, that's multiplication. That's 3 times 4/3. Whoa. I multiply by the reciprocal. And I get 4. So essentially, what we just showed was why, when you're dividing by a fraction, you multiply by the reciprocal. And that's a good place to stop this recording.